Inside this video, we're going to learn new buzzword inside the Java ecosystem, which is GraalVM. Please watch the complete video. I'm going to show you a demo of GraalVM with the help of simple Java program and also with a SpringBoot application. So what is a GraalVM? GraalVM is a special JDK which built by the Oracle team based upon their 10 years of research. They have started this GraalVM project internally around 2011. So it's more than 10 years, and based upon this 10 years research, they have built a new JDK, and with the help of this high performance JDK, we can build Java based web applications or Java based applications or cloud native applications that can run fastly and require few compute resources, and most importantly, these applications they can start instantly. Typically a Docker container or Spring Boot application, regardless of how much optimization you do, it will take at least 10 seconds of time. But with the help of GraalVM, we are going to start our web applications instantly. There is a lot of magic that will be done by the GraalVM behind the scenes. Before we try to understand in detail about the GraalVM, let's try to understand how this GraalVM is going to help me or how it is going to help my organization. Because you may have a question like, why should I use GraalVM when I'm good with the traditional OpenJDK or Oracle standard JDK? It's a very valid question. Let's try to answer that. In the last few years, business, they want to build innovative applications and they want to go to the market as soon as possible. And they are trying to automate most of the process. To achieve all these things, organizations and teams, they want their applications to run fast and consume few memory and CPU resources. Why organizations, they want their applications to run fast and consume fewer resources? Because these days, most of the organizations, they are running their traditional applications or cloud native applications like microservice, serverless inside the cloud. So if your applications runs fast and if they consume very few resources, you are indirectly reduces the cost of the cloud bill and also improving the efficiency of your Java application. If your organization is looking for such fast applications that are going to consume few resources, then you should definitely use GraalVM. With GraalVM, without making any code changes inside your web application, your application performance is going to be improved to a great extent. And how this is happening is, behind the scenes, GraalVM built based upon a state-of-the-art new JIT compiler. We are going to talk what is JIT compiler and how it is going to improve the performance in few seconds. With the help of this new JIT compiler, GraalVM is going to improve your application performance, lowest required memory per operation, and also reduce your cloud bill. Overall, in simple words, if you ask me what is a GraalVM, GraalVM enhances entire Java ecosystem by offering a new, better performing JDK. Let's try to understand in detail about this new JDK, which is GraalVM. First, let me show you what happens in a normal OpenJDK or normal Oracle standard JDK whenever we try to run a Java application or a Java program. As a developer, first you write your Java program, and we call this as a Java source code. And this source code has to be compiled. For the same, we are going to initiate a command which is Java C. So to this Java C command, we are going to pass what is our Java class name. With this command, my source code will be compiled to a bytecode. Like you can see, post the compilation, I'll get my compiled code inside a file with a .class extension. And this bytecode can be only understood by my JVM. Bytecode is a black magic that makes our Java code compatible and platform independent. So I can take this .class file and I can give to my friend who is using Windows OS or Linux OS. Right now I can do my compilation in Mac OS and I can send this to my friend who is using a different OS. He don't need to understand my Java program. He don't need to compile again. He can simply take this .class file and give this as an input to the JVM by executing a command called Java hello. So with this Java hello command, my friend is trying to execute the Java program. So as soon as my JVM receives this input, behind the scenes, it is going to follow a lot of activities. And towards the end, it is going to execute my program and display the output. This is what happens in normal JDKs. And here, my JVM is a platform dependent. So whenever my friend is trying to execute my bytecode in his mission, he need to install JRE or JVM, which is specific to his OS. So JVM is a platform dependent, which is making my Java program as a platform independent. So these are all basics. I hope you are clear with all these basics. Now let's try to understand what exactly happens inside my JVM when my friend is trying to give the bytecode as an input and how this output is coming. So let's try to understand step by step. In the very first step, the class loading will happen. So my bytecode, which is in the .class file, will be loaded into the memory. That's what we'll call it as class loading. If you have a big Java web application or Spring Boot web application, you'll have a lot of dependencies in the format of jars. In such scenarios, all your jars and classes will be extracted and loaded into the memory with the help of this class loading. Once the classes or the bytecode is loaded into the memory, bytecode verification will happen. For security reasons, my JVM is going to perform bytecode verification to make sure no one altered or no one using illegal typecast or trying to access private fields. So such kind of security checks and Java language specification violation checks will be done by my JVM inside this bytecode verification. Once my bytecode verification is successfully completed, then my JVM is going to invoke a just-in-time compilation, which is JIT in short form. This JIT is an interpreter. What is the purpose of interpreter in any language? It is going to convert the instructions present inside a program into a format where a mission can understand. The same job is being done by the JIT compiler here. It will try to convert all your bytecode into the mission code. Apart from converting your bytecode into mission code, this JIT compiler also is smart enough to identify all the bytecode that is going to frequently executed, which are known as hotspots. So it is going to optimize these hotspots by translating them into a highly optimized mission code. It's a kind of caching your bytecode in the form of mission code. So if you see what is happening here is on the fly, dynamically, my JIT compiler is converting the bytecode into the mission code. If I try to execute a program or if I try to execute a business logic, the bytecode related to that will be dynamically compiled and the same will be converted into mission code. Of course, there will be a lot of optimizations done by this JIT compilation so that it don't have to unnecessarily convert all the bytecode every time. That's why our Java programs, they work without any performance issues. Now, after this JIT compilation is completed, whatever mission code that is right now available will be executed by the JVM with the help of the native processor. So this is what happens in a normal JDK. Now let's try to understand what is going to happen with the GraalVM JDK. GraalVM comes in two different modes. The very first mode is JIT mode. In this mode, the GraalVM JDK is going to work very similar to traditional JDK. Let's try to understand what is going to happen in JIT mode. If you see, first there will be a Java program, then you try to compile it with the help of javac hello.java, and the same will be converted into .class file. The same you will give as an input to JIT compiler. Inside the GraalVM, there will be a JIT compiler component. So whenever you try to run the java hello command, the normal JIT compiler or traditional JIT compiler will come into picture and it will give the output. So there is no magic is happening. In this mode, it is going to work in very similar style of normal OpenJDK or traditional JDK. Oracle team, they also claim that even if you use this normal JIT mode inside GraalVM, it is going to improve your application performance without making any code changes. Now coming to the interesting mode inside the GraalVM, which is AOT mode. So inside this AOT mode, the compilation or the conversion of bytecode into mission code will happen ahead of the time. That's why we call it as AOT mode. So JIT means just-in-time compiler, whereas AOT means ahead of time compiler. So let's try to understand what is going to happen inside this AOT mode. First, there will be a Java file. You will compile that and there will be a .class file will be generated. To this point, the story is very similar. Now let's try to see the magic. When you issue a command which is native-image followed by what is your .class name, the AOT compiler or the AOT mode come into picture inside the GraalVM. What is so special about this AOT compiler? Let's try to understand. With the JIT compiler, the conversion of bytecode into mission code and the execution of the same mission code and translating that into output, everything is going to happen in a single step. Whereas with AOT mode, it is going to be divided into two steps. In the very first step, your GraalVM AOT will convert all your byte class code into a native executable code or native mission code. So now you have a native executable code and you can give this native executable code to your friend, but please make sure if you have used macOS to run this native image command, your native executable code will only work in your friend mission only if he or she is using macOS, because this native image or AOT mode is going to convert your bytecode into the mission code based upon the platform where it is being executed. So what is the advantage with it? The advantage with this is when you give this native executable code to your friend who is using macOS, or if you compile it with the Linux inside your local, and if you try to execute the same inside the cloud server which is using Linux operating system, first they don't need a JDK or JVM or JRE inside their mission install. The reason is this native executable code package will have all the components needed to execute this Java program, and it does not require any JVM because there is no need of converting your bytecode to mission code at runtime. It is already converted. It just needs to be executed. That's why you can take this native executable code and deploy into server. And this executable code, if you try to invoke with a command, it is going to run instantly. It is going to give your output instantly. There is no dynamic conversion of your bytecode to mission code. All that happened already. Here you may have many questions what we are going to get with all this AOT mode or AOT compiler. I am going to show you few demos which will make more clear to you. On a high level, your GraalVM is going to have two modes, JIT mode and AOT mode. If you use normal Java command, it is going to work in a traditional style with the help of JIT compiler. But whenever you are using native image command, behind the scenes, your GraalVM, which has native image utility, it is going to invoke the same, which will compile your applications ahead of time into native executables. These executables are smaller, start nearly instantly, and consume a fraction of the compute resources needed to run the same Java application on a traditional JVM. That's why this GraalVM is ideal for cloud deployments and microservice serverless deployments. And these native executables, if you compare with native programs like C, C++, they are working very equivalently in terms of startup, memory usage, and performance without leaving the powerful ecosystem of Java. I'll show all these advantages in a demo. First, let's try to write a small Java program and try to invoke this JIT mode and AOT mode and see what is the differences between them, what is the performance improvement that is happening. So let's try to understand all those details. To get started with the GraalVM, please make sure you are installing the GraalVM JDK. For the same, you can visit this website, which is graalvm.org. Here, if you can click on this download button, you can select the GraalVM JDK version. As of now, you can see it supports from Java 17 only. Please make sure you are selecting at least Java 17 here. So I'm selecting this Java 17. Post that, you can select your platform based upon your operating system. Instead of manually installing and following all these steps, you can also use SDK man. With the help of this SDK man, we can install any softwares very quickly. First, you need to make sure you're installing this SDK man with this curl command. Post that, you can simply run this SDK command, which is SDK install Java and what is the version of GraalVM. So if you can copy this value and execute inside your terminal, the GraalVM JDK will be installed and the same will be set inside your Java home and path variable automatically by the SDK man. So there is no manual work involved here. I have followed the same, but if you are looking for manual process where you want to install and you want to set the path manually by yourself, come to this GraalVM homepage, and here you can click on this Get Started and select the operating system that you are using. For example, I'm using Mac OS. I can click on this Mac OS, and here there are all manual steps described. By following them, you can easily install and activate GraalVM JDK inside your system. So I already installed this GraalVM JDK behind the scenes. We can also confirm the same by running the java-version. You can see this is the output. If you have a JDK which has GraalVM, you can see this GraalVM inside the output. If you don't have this GraalVM inside your output, then it is not a GraalVM JDK. It's a normal JDK. So please make sure you are installing GraalVM JDK. So now I'm inside a directory on my desktop with the name GraalVM. Inside this, first I'm going to create a new file with the name hello.java. So this is the file name that I want to simply create. Now I can go to the folder. Inside this GraalVM folder, you can see I have these hello.java. So let me open this. So this is the empty hello.java file. Here I can try to write some Java code like public class hello. This is the class name. Post that, I also want to write a main method which is public static void main. So inside this, I'm simply going to write a system.out.println. To this println statement, I'm just going to pass a string which is hello GraalVM. So this is what I have. This is a simple Java program. There's nothing complex here. Now I have saved these changes. First, like we discussed, regardless whether we are using AOT mode or JIT mode, we should first compile our Java program. For the same, the command is javac hello.java. So if I try to run this, behind the scenes, a .class file will be generated which will have the bytecode related to my Java program. So now first let's try to run this program with the help of just-in-time compiler inside the GraalVM. For the same, you just have to use the same Java command, and to this you need to run the command java hello. So you can see I'm getting an output. You'll follow the same steps even with the normal traditional JDKs like OpenJDK. Now let's see the magic of AOT. To see the magic of AOT or ahead of time compilation with the help of GraalVM, first we need to invoke the command native-image and what is your class name, which is hello. So whenever I try to run this command, all the bytecode will be converted into my mission code along with all the relevant dependencies. Since it is going to do a lot of work behind the scenes, the compilation time is going to take longer compared to normal JIT compilation. In the JIT compilation, everything is going to happen at runtime. If you have 100 classes, it is going to do the JIT compilation of each class whenever it is invoked. Whereas with AOT compilation or ahead of time compilation, this is going to scan all your code and make sure it is generating a compact package that is natively executable with all the dependencies, including the garbage collector, which is going to be useful at runtime. Since it is going to do all this job, it is going to take a good amount of time. So that's why if I try to execute this command, you can see it will do a lot of steps behind the scenes. So let's wait for this to complete. It is also printing some reports. So you can see it took around 18 seconds to compile a simple Java program. The only drawback of this AOT is it is going to require a lot of time for your compilation. Apart from this, it has many other advantages which we are going to discuss in few minutes. If you see here behind the scenes, it has performed all these analysis, like it found so many classes, so many fields, so many methods. Since they are going to be Java libraries also, it scanned everything and it pulled all the classes, methods that are needed for your Java program to be executed. Now let's go to the folder. You can see here now I have the natively executable code generated, and if I try to see the memory, it is 6.4 MB size and it is a Unix executable file because I am using Mac OS. Here you may have a question like why it is 6.4 MB whereas hello.class is only 417 bytes. Reason is it has all the dependencies to be executed at runtime without the need of JRE. By taking this 6.4 MB executable file, you can run this program in any Mac system without installing JDK or JRE, and this is going to run very fastly compared to traditional programs. We'll go into detail how it is achieving this. Now let me try to execute this natively executable code. For the same, let me clean the console first. Now you just need to invoke the native executable code. The name is hello. So let me try to execute this, and you can see I'm getting the same output. This time, just to show you the metrics of both JIT and AOT compilation, let me run the same commands with the help of time. I'm using a command time inside my Mac OS, which will give me the total time it took to execute the command. So first, JIT compilation, I'm trying to invoke with the help of Java. And what is the Java class name? The Java class name is hello. So if I try to execute this, you can see I'm getting an output. In total, it took 0.084 seconds. It is using 81% of CPU. So these are the other metrics that we have. Now, if I try to execute the same native executable code, but before that, let me give a prefix command, which is time. So now you can clearly see the very first time, which is user time, it is taking 0.0 seconds. And the next metric, it is also taking 0.0 seconds. Coming to the CPU utilization, traditional JDK is taking 80% of CPU utilization, whereas this native executable code, it is taking 61%. So you can see there is almost 20% improvement. Now coming to the total time, this took 0.084 seconds, and this is taking only 0.008 seconds. You can see that drastic improvements that we are able to achieve by following the GraalVM. Of course, there is a delay during the compilation time. That's fine, because eventually we want our mission code to be deployed into a server. In the server, we won't do again compilation. That's why it should not be a big drawback, with the advantage that we are getting here, where we are seeing a lot of application improvement without making any code changes. If you can imagine, with a small Java program, I'm able to see such a difference. As a next step, let's try to take a SpringBoot application and try to see how this GraalVM JDK is going to bring lot many advantages or lot many improvements into my SpringBoot application. I have taken a sample SpringBoot application with the name accounts. The same I'm going to upload inside the GitHub repo, and I'll provide you the GitHub repo link inside the description. This is a simple SpringBoot application that has 4 different APIs inside this account controller. Inside this SpringBoot application, I have followed all the standards like documenting the REST APIs with the help of OpenAPI specification and Swagger, along with building 4 different APIs which supports create account, delete account, fetch account, and update account details inside a bank. So with the help of this create account, you can create an account inside the bank, and very similarly, you can fetch the existing bank account details, and we also have update account details. And at last, we also have delete account details. Inside this SpringBoot application, I also followed all the standards like exception handling with a global exception handler, doing auditing with the help of Spring Data JPA, following the DTO pattern. And apart from that, I'm also using a H2 database. These internal H2 database details I have configured inside the application.yaml, and the application is going to start at the port 8080. And inside the schema.sql, I have mentioned the scripts to create 2 different tables, one with customer and the second one is accounts. So during the startup of the application, these tables will be created, and into these tables only we are going to save all the accounts related information. The reason why I'm telling all these details is, if you see, this has most of the functionality that Spring Boot provides. I'm using Spring Boot Starter Actuator, I'm using Data JPA, I'm using Web Starter, I'm using H2 database, Lombok, I'm using validation dependency, I'm also using OpenAPI specification dependency. So this is a very good application where we can try to leverage GraalVM JDK and see how this is going to make the difference. First, whenever you're trying to leverage the GraalVM JDK, you need to add the plugin related to the GraalVM build tools, which will help us to convert these Spring Boot web application into a native executable code. You don't need to type all these details. Whenever you are trying to create a Spring Boot application with the help of start.spring.io website. So this is a website where you can add all the Spring Boot dependencies. So I have selected Maven, language as Java, and Spring Boot version. Here inside the dependencies, you can search for GraalVM. So you can see there's a GraalVM native support, which you can select. And as soon as you click explore, there is not going to be any dependency that is going to be added. Instead, this plugin related information will be added into your pom.xml. Usually we'll only get Spring Boot Maven plugin, but since we are trying to use the GraalVM, we should also need these native Maven plugin inside our pom.xml. You just need to copy these content and paste inside the pom.xml and do a Maven build. You should be good with that. Now, if I try to go to the properties of my project, here inside the project settings, I'm going to modules and I'm making sure for my module, which is accounts, I'm using a normal JDK. So under this module SDK, I'm going to select these 17. So this is a normal JDK inside my mission. I'll click on this OK. Now, as a next step, I'll try to compile my application. Once the build is completed, we can go to the Spring Boot main class, which is accounts application. And here I will try to start my application in debug mode. And you can see as of now, it is using standard JDK. And the time it took to start my application is around 8.4 seconds. I can also try to do the same again. So let me stop the application, clean the console, start the application again in debug mode. This time also it is using normal JDK. So let me see how much time it is taking to start my application. It took around 9 seconds. This time what I'm going to do is I'll go to the same accounts project settings. So here there is a open module settings. I'm clicking on that. I'll go to modules. This time what I'm going to do is I'm going to select the GraalVM specific JDK, and that is present with a different 17 inside my system. So let me select this. So this is a GraalVM JDK. If I click on this edit, you should be able to see this is the path of SDK man, and you should be able to see all the Graal related packages here. So this confirms we selected a GraalVM JDK. Click on OK. And now I'm going to delete the content of target folder just to compile the application again with the GraalVM JDK. So I'm just compiling here. Now, when I try to start my Spring Boot application, behind the scenes, it is going to use the GraalVM JDK. So I'm trying to start my web application in debug mode. This time you can see it is taken only 2.616 seconds because I'm using a JDK which is specific to GraalVM. You can see from 9 seconds, we reduce the time to 2.6 seconds. Such a drastic improvement without making any code changes. I have not even went into the AOT mode of GraalVM JDK. We are still in the just-in-time compilation of GraalVM JDK. Oracle team, like they claimed, behind the scenes, even normal JIT compiler also is going to bring a lot of improvement to your web application or to your Java application. This is a live example. The same Spring Boot application, which was taking around 10 seconds to start with the normal JDK, now it is taking only 2.6 seconds. I can try one more time. So let me start the application, clean the console, and try to start the application again in debug mode. You can see this time also it is taking only 2.713 seconds. I'm assuming you're liking GraalVM JDK here. Now let's see the black magic that is going to happen whenever you are using ahead of time compilation with the help of GraalVM JDK. So let me stop my server. In order to compile our Spring Boot web application into a native executable code, we need to issue a Maven command. Before that, let me try to clean the console. First, I want to increase the memory allocation to my Maven. So with this export Maven underscore OPTS, I'm trying to assign 6 GB of memory to my Maven command that I'm going to execute inside this terminal session. The reason why I'm providing a lot of memory to my Maven is, like we discussed previously, during the compilation with AOT mode, it is going to scan all the thousands of classes, methods, fields inside your web application, and it is going to convert all that code into a native executable code. For that, it is going to require a lot of time, and at the same time, it is going to require a lot of memory. That's why I'm trying to provide this memory. Otherwise, you'll be seeing that Maven native image compilation will fail. So first, let me execute this command. Post that, I'll try to delete the content of the target folder inside the accounts project, just to make sure to understand what is being generated by the AOT compilation. So now I'm going to run a Maven command, which is mvn space clean space -p native, and post that native : compile. So this command will tell to my Maven plugin to compile my code into a native executable code with the help of GraalVM JDK. When you're trying to issue this command and for your project or inside your local Java home, if you don't have GraalVM JDK, it is going to simply throw the exception. So that's why please make sure you have the GraalVM JDK inside your Java home path. So I'm trying to execute this command, and this is going to take easily 5 minutes because behind the scenes, it is going to do a lot of analysis. While this is happening, let's try to understand what exactly happened during the AOT compilation with the help of GraalVM JDK. First, you'll make sure you have written all your application classes and you have provided all the required libraries, required JDK. In this case, it should be a GraalVM JDK. And inside the GraalVM JDK, there is a substrate VM, which is going to do the magic of converting all the code into a natively executable code. So this we are going to give as an input to the GraalVM JDK. So behind the scenes, what will happen internally is my GraalVM AOT compiler, it will continuously do iterative static analysis of the code until a fixed point is reached, which means my GraalVM scans all the reachable classes, methods, fields, and any unused code will be ignored. Reachable classes means it is going to do static analysis. How many classes are there? What is the main method? From the main method, how the execution is going to be happen? What are the REST APIs inside? What are the beans? What are the components? What are the database configurations? What are the dependency libraries? What are the classes inside them? So all such static analysis will be done continuously multiple times till a valid fixed point is reached. And here the GraalVM has a challenge or a limitation. If your web application or if a library inside your web application uses dynamic code concept like reflections, in such scenarios, GraalVM does not know that. It cannot detect the dynamic invocations with the help of reflections or any dynamic resources invocation. So in such scenarios, you as a developer need to provide the reachability metadata to the GraalVM. GraalVM team, they have recommended to provide this reachability metadata with the help of configurations by using formats like JSON inside our web application. So whenever we provide such configurations, then GraalVM knows what are those Java reflection classes that you are using, what are those dynamic proxies you are using, what are the Java native interfaces you are using. So all those can be analyzed and the same can be converted to the native executable code. If you are not providing this reachability metadata, definitely your application will not work like expected. I'm going to share more details about this reachability metadata in few minutes. After this continuous analysis, this AOT compilation will generate a natively executable code. I hope this is clear. Now let's try to see what is the output inside the terminal. So here you can see my terminal still executing the commands. If you see the metrics here, it has scanned over 40,000 classes, and out of them, it identified only 37,507 classes are reachable, which means the remaining classes it is going to ignore. And similarly, it has identified 86,000 fields, out of which only 60,547 fields are being used inside our application. Coming to the methods, you can see there are 3 lakhs methods it is trying to scan, out of which only around 2 lakhs methods are being used. Since this amount of work is being done behind the scenes, the GraalVM JDK is going to take a lot of time for AOT compilation. If I have provided more memory like 8 GB or 10 GB to this command, then it should have completed in more shorter period. But for now, let's wait and see what it is going to happen. Finally, the build process is successful. We can also use this quick build mode by specifying this OB argument, which will speed up builds during the development. So only during the development, if you are looking for a native executable code as quickly as possible, then you can pass this argument. For now, let's go to the target folder and try to analyze what is generated by my GraalVM JDK. So here inside my target folder, you can see there is a native executable code with the name accounts. So this will be same as your project name. So here the beauty, you can see there is a jar that got usually generated. This is a fat jar of SpringBoot and it is 56.3 MB. Using this jar, usually you can deploy the SpringBoot application into the cloud server or as a Docker container inside Kubernetes clusters. So you can do whatever you want by taking only with this 56 MB. But now the native executable code that got generated is 182 MB. What I'm getting here with this more memory. Please remember, with the jar that you have, which is of type 56 MB, to execute this jar as a SpringBoot application, you need local JRE or JDK install inside the Docker image or inside a Kubernetes cluster or inside the cloud server where you are trying to deploy. So when you try to add the JRE, you'll get 200 MB more, which will make your application around 200 to 300 MB. Whereas this native executable image, you need only this executable image. You don't need JRE installed inside your Docker container or inside the Kubernetes cluster or cloud server. With that, the size of your Docker container or any other package is going to be reduced to a great extent. We'll explore that in few minutes. But for now, let's try to start the Spring Boot application by executing this executable code. For the same, I'm going to clear the console. My executable code present inside the target folder. That's why I need to go to the target folder, and inside this, I have a executable code with the name accounts. So if I try to start this application, you'll be seeing the magic here. So 1, 2, 3, go. So you can see my Spring Boot application started in 0.159 seconds, which is like typically 150 milliseconds. So it's like as good as instant. Within 0.1 second, our application started. So in this 0.159 second, we're also doing some table creation inside the H2 database. If you don't have this table set up during the startup, it might have started even more quickly. So that's the advantage that you're seeing here. We can also test this application. So inside my Spring Boot application, with the help of this API path, I'm trying to create a new account by passing the name, email, and mobile number. So you see, I'm getting a successful response. I can also validate that by passing the same mobile number inside the get API with the help of this query param and clicking on the send. You see, I'm getting a successful response. And the time it took is 7 milliseconds. And the same like for the insertion operation, it took 32 milliseconds. So overall, the startup of your application is increased to a great extent from seconds to milliseconds. It is like 100 times improvement in the startup of the time. And this application is going to occupy less size inside your servers and Docker images. And moreover, it is going to consume less memory at the runtime, because there is no need of just-in-time compilation at the runtime whenever a new class invocation or whenever a new method invocation is happening. Everything is already compiled into mission code. Since that overhead will not be there during the runtime, you don't need typical JVM. You will not be following typical runtime activities except garbage collection. So since all this is not happening, the memory consumption by your application at runtime is going to be very less. So let me stop this application. I'll try to start the application, and again I'll show this time also it is going to start instantly. So you can see this time it took only 0.12 seconds. I'm sure if you don't have these insert commands, it is going to take even less time. This is starting instantly, and this will open new opportunities in the cloud native applications like microservices applications, Docker containers, and serverless architecture. So inside serverless, you only want your application to be running only when a request is coming towards it. So all these days, there are some challenges like your application require like typically 5 seconds or 8 seconds or 10 seconds or 2 seconds to bootstrap the application and accept the request. So this has some challenges. That's why most of the companies, they are using for asynchronous purpose only, not for the synchronous communication. Whereas with this, it opened new opportunities. I hope this is clear. Now let me take this discussion towards the Docker, because with the help of Docker, we can generate Docker images, Docker containers, and see how this is going to impact. If you're not clear about Docker, Docker containers, microservices, all this discussion, there is a Udemy course from me focusing on microservices. You can refer the same and try to register. I'll try to provide all my Udemy courses links inside the description of this video. For now, let me stop this application and clear the console. Before we try to generate the Docker images, first make sure the Docker is running inside your local system. I already have Docker installed inside my system. I'm trying to start the same now so that we can generate the Docker image. Now let me go to the pom.xml. Like I said before, we can also reduce the build time whenever we are using GraalVM by mentioning a build configuration. For the same, just after this native Maven plugin, I'm going to make some configurations with the help of this configuration tag. Inside this, I'm mentioning build args. Using this build arg, I'm passing a value which is OB to optimize the build process in GraalVM AOT compilation during development. So please don't use this whenever you are trying to generate a native image code for your production deployments. So once we make these changes, you can load the Maven changes. Now my Docker started successfully. First, I'll try to generate a Docker image without native executable code, and I'll show what is the size of your Docker image and how much time it is taking to start the container from your image. In order to generate a Docker image, we can use this SpringBoot Maven plugin. By using a Maven command, we can generate a Docker image from a SpringBoot application. And behind the scenes, my Maven is going to use the concept of build packs to generate the Docker image. If you are interested in more details about this, please enroll my microservices where I talk about this in detail. So first, I'll go to my terminal, and here first I'll try to run the Docker images. As of now, you can see there is no Docker image with the name accounts. As a next step, I'll go to pom.xml. Here for my SpringBoot Maven plugin, I need to provide some configurations with the help of this configuration tag. Under this configuration, I'm going to invoke one more tag, which is image. Since we are trying to generate a Docker image, we need to provide the name for our Docker image so that using the same name, the Docker image will be generated. Here I'm mentioning the name of a Docker image by using this name tag. So the name that I want to follow is easybyte/artifact ID from the pom.xml. So this project.artifact will come from the artifact ID present in the top. So this is the artifact ID that we have. So account's name will come into my Docker image name. And post that, what is the tag name for your Docker image? So right now I have the tag name as native. We can use this when we try to generate a Docker image using GraalVM JDK. For now, let me mention a name which is normal. So this is a normal Docker image generated with the normal JDK. I'm not going to generate a native code specific Docker image. So let me load these Maven changes. Post this, I'll go to the terminal. Inside the terminal, I'm going to run a Maven command, which is mvn spring-boot:build-image. So with this build image command, I'm telling to my Maven plugin to generate a Docker image with the help of build packs. So let me execute this command. So this will do the normal Git compilation and it will try to generate a Docker image. So this will take few minutes. After few seconds, this process is completed. You can see in total it took 51 seconds to generate a Docker image based upon Git compilation. If I try to run the Docker image command right now, here you'll be able to see a new Docker image with the name easybyte/accounts. The tag name is normal and this is the image ID. You can see the total size is 314 MB. Previously, we saw that SpringBoot jar inside the target folder has only 50 MB. So inside this target folder, if you see, this jar has only 56 MB. But when we try to generate this Docker image, the Docker image size became 314 MB because the major space is going to be taken care by your JRE. To run my Spring Boot application, I need a JRE. That's why my Docker image has all the dependencies needed to run my Spring Boot application, including JRE. Now let me convert this Docker image into a container by running the command, which is docker run -p followed by port mapping 8080 and 8080. Since my Spring Boot application is going to start at 8080, I want to expose at the same port number. Post that, we need to mention what is the Docker image name. The Docker image name is easybyte/accounts. Post that, what is the tag name? The tag name that we have here is normal. So let me execute this command. My Spring Boot application is being started by the Docker as a container and it is going to take good amount of time. Let's wait for this to complete. So it is taking its own time. I think it is going to take at least 30 seconds. You can see it has taken around 32 seconds to start my Docker image as a container. Think like inside a Kubernetes cluster, you have a microservice. You want to onboard more number of instances dynamically whenever you want. So whenever you try to onboard a new instance, it is going to take at least 30 seconds to start your container. Then only it is going to accept the new request. So this is one of the challenges that companies are facing. Usually these applications require a lot of bootstrap time. So let's try to see how this is going to change when we try to migrate to the GraalVM JDK. For now, let me stop this container. Post that, I'll clean the console. Let's try to start the application one more time to make sure what is the time it is taking to start my Spring Boot container. So this time also, I think it is going to take 30 seconds at least. Do you have any guesses? I think everyone is going to guess 30 seconds or around 30 seconds. Let's see. So right now, H2 console is being bootstrapped. Now JPA scanning is completed. Tables are created successfully. This time also it took around 33 seconds. So we're good. Let me stop this and let me run the clear console and run the Docker images command. So please remember the Docker image size for normal Docker image that we generated with the normal JDK has a size of 314 MB. Even it is taking around 32 seconds to start the container. Now, I want to generate a Docker image based upon the native executable code. For the same, we just need to do few configurations here. Inside the pom.xml, where we have mentioned the image related configurations under the Spring Boot Maven plugin, here I'm going to add few more configurations. Don't worry, you're going to get all these configurations from the GitHub repo. I'm just pasting these to save some time here. Suppose that, let me load the Maven changes. So here, what I'm telling to my build pack is, I don't need any JRE or JDK inside my Docker image because all the code that I'm going to have inside my Docker image is of type native executable code. So for the same, we are telling, please generate a Docker image by using this builder, which is not going to use any JRE. Post that with the help of these environment variables, we are telling where our normally compiled Spring Boot jar is going to present. So it is going to present under target folder with the name, accounts, so and so version and snapchat.jar. I mentioned the same. So my GraalVM JDK behind the scenes, it is going to scan all the code present inside this jar along with all the dependencies and generate a natively executable Docker image. The next property that I have mentioned is BP native image. With this BP, which means build pack native image as true, I'm telling to my build pack to generate a Docker image which has this native image executable code. So let me save these changes. Post that, I'll go to my terminal. Here inside my terminal, I need to run the same command, which is maven spring boot build image. So this is going to take a good amount of time, at least 10 minutes it is going to take to generate a Docker image. So I'm trying to execute this command. While this is happening, meanwhile, we can discuss more details about GraalVM. So let me go to the presentation. While the Docker image is being generated behind the scenes, let's try to understand the advantage of GraalVM. The very first and major advantage of GraalVM is it is going to start your applications instantly. We have seen the applications are being started within milliseconds. You can take the native executable file and the same you can deploy it inside your servers or any serverless environment or as a Docker containers. It is going to start your application instantly. You may have a question here how this is happening. Like we discussed, whenever we try to run an application with a traditional JDK, JIT compiler will come into picture, and the JIT compiler, it has to do lot many tasks at the runtime whenever you are trying to start your application. These tasks, like first it has to load the jars from the disk. Post that, it has to extract the class files from the jar files. After this, it is going to verify all the class definitions, followed by running any interpretation logic to convert all your bytecode into mission code, followed by profiling has to be done by your JIT compiler for optimizations at the runtime. After profiling, it is eventually the bytecode will be compiled into a mission code. Once this compilation is completed, at last, your application is going to start with a full speed. So since the JIT mode, it has to complete all these tasks whenever you are trying to start your application, it is going to take few seconds. Now coming to the AOT. In the AOT, the very first step it will do is, it will load the natively executable code from the disk, like whatever native executable code that got generated from the AOT compilation, and it does not need to do any bytecode conversion to mission code. You don't have to validate any class definitions. You don't have to do any interpretation logic, profiling logic, because this already completed during the AOT compilation. That's why straight away from step 1, which is loading the native executable code from the disk, it is going to start your application instantly. That's why the app is going to start instantly. So in simple words, since the number of steps with the GraalVM is less and the code is ready for execution inside the native format, the start time will be less compared to the traditional JDKs. Inside traditional JDKs, you always give the compiled classes or compiled jars to your web server or app server. Whereas with GraalVM, you are going to provide directly the natively executable code. Now let's try to understand other advantages. The other advantage is it is going to consume very low memory at runtime, which is going to save your cloud bill. Similarly, the size of your application code is going to be packaged with the required components. That's why the packaging is going to be very compact, since it is not going to have any JRE, and at the same time any unused methods, unused fields, everything will be ignored by the AOT compilation by the GraalVM. So here also you may have questions like why low memory consumption, why compact packaging. So let's try to understand this. In a traditional JIT mode, during runtime, all these tasks will be happen whenever you're trying to execute your code. There'll be a garbage collector which will continuously monitor. There'll be a dynamic code caching has to be done whenever a new bytecode is getting converted into mission code. And there'll be a runtime virtual vision like JVM has to be there along with the compiler. There'll be continuous profiling feedback will be happening. There'll be class meta definition will be maintained. There'll be application payload, which is specific to your application, is also present. So since all these tasks has to happen dynamically, continuously, they require more memory. Whereas in the AOT module, the only tasks that are going to happen is garbage collection, and you already have your application mission code. That's why you don't need any JVM or compiler. There is no need of dynamic code caching, profiling, class meta definition. All this is already completed during the build process of AOT. So along with the application mission code, you will also have application payload, which is specific to application. So since the number of activities at runtime by AOT are less, it will consume less memory compared to JIT. And coming to compact packaging, like we discussed, AOT does not require any traditional JVM components and ignore all unreachable code or dead code. That's why the size of AOT generated executable code will be less. We are going to validate this compact packaging advantage with the help of Docker image size in few minutes. Now moving on to the next advantage. With the GraalVM JDK, we are going to have reduced attack surface. The reason is only the code reachable by the application are included in the image, and no new code can be loaded at runtime. Because there is no runtime interpretation concept here, all the code will be scanned by your application during the build process, and only the reachable code will be present inside your native executable image. All unused libraries, unused code will be ignored by your GraalVM. And similarly, concepts like reflection, deserialization are by default disabled. And if you want to consider some reflection classes or dynamic code, we need to define explicitly the reachability metadata configuration, like so and so class I'm going to use with the help of reflection, so and so object I'm going to deserialize. I will explain what is this reachability metadata configuration in few seconds. And the next advantage that we have here is polyglot support. This GraalVM JDK is going to support to build your applications with multiple languages. Like you can have Java, Kotlin, Scala, Groovy inside your application, and at the same time you can also use famous languages like Python or Ruby, JavaScript, or any low-level language like C, C++, which means inside the same application I can write a Python code, Java code, JavaScript code, or any other languages code. And GraalVM JDK is going to make my life easy by making all those work seamlessly. Because at the end of the day, regardless of any language that you use to write your program, when they get converted into the natively executable code, all the programming instructions are going to be same. That's why GraalVM is going to take care of the heavy lifting, where it is going to take the inputs from all the different languages that you have used inside your application, and eventually it is going to generate a natively executable code which will work seamlessly. So this will open new opportunities. In Java, there is already opportunities where we can write other languages inside the Java application, like we can write JavaScript. But all these days, developers, they have to do a lot of setup. It is a complicated process, but now with the help of GraalVM, it is going to be super easy. If you are interested about this feature, you can look for the official documentation inside the GraalVM website. So with this advantage, GraalVM adds the ability to efficiently mix multiple languages in a single polyglot application, and the execution speeds are going to typically exceed those of the original language runtimes. So I'm talking everything, all the advantages of GraalVM. Do you think there are no disadvantages? You may have a question like, is GraalVM too good to be true? Definitely there are some challenges. GraalVM is not your silver bullet for all your problems. So there are certain limitations. You need to understand those limitations, and accordingly, you need to use the GraalVM JDK. The very first limitation is GraalVM do a lot of static analysis, and it may not automatically detect all your runtime code that you have written with the help of reflection code, JNI, dynamic proxy code, etc. inside the Java. So all such code by default will not get scanned and will not get converted into the natively executable code, which means your application will not work if you're trying to use dynamic code. That doesn't mean we cannot use GraalVM for the applications where we have dynamic code implementations. There is a workaround like we discussed. The workaround is to provide this information manually to the GraalVM using reachability metadata. So with this metadata, we're telling to GraalVM, these are the reflections, these are the dynamic proxy code, these are the dynamic resources that I'm using. So all such information, if you provide using the configurations, the GraalVM is going to take care of it behind the scenes. So here, definitely you may have a question like, I can provide all this reachability metadata if I have written any reflection code inside my web application. What if my dependency libraries or frameworks are using a lot of these reflections? This is a very valid question. SpringBoot itself uses a lot of reflection code, dynamic code inside the core concepts of Spring like aspect-oriented programming. For all such frameworks, do I need to provide? It is going to be super complex task. To overcome this challenge, Oracle team, what they are doing is they are requesting all the owners of the libraries and frameworks to maintain all these reachability metadata inside a GitHub repository. So this is the GitHub repository where all the frameworks like Spring, SpringBoot, Quarkus, Hibernate, Micronaut, Helidon. So all these major frameworks, they are already maintaining this reachability metadata inside this GitHub repository. And at the same time, they also integrated this reachability metadata in the latest versions. For example, SpringBoot from the SpringBoot 3.0, it has embedded all these GraalVM reachability metadata inside the SpringBoot libraries itself. So there is no need for this GraalVM reachability metadata if you are using latest versions of SpringBoot. But for some reason, if you are getting some error, you just need to tell to the GraalVM, please go ahead and look for the reachability metadata, and it is going to take care of behind the scenes. So let's see what is there present inside this reachability metadata. If you try to Google GraalVM metadata, so this is the very first GitHub link, and this is the GraalVM reachability metadata where all the major frameworks and libraries are maintaining their metadata. If you click on this metadata folder, you see all the major libraries and frameworks. They are already maintaining metadata information like ActiveMQ they are maintaining, OpenTelemetry they are maintaining, HTTP client they are maintaining, JT server they are maintaining, and very similarly Hibernate they are also maintaining. You can see how important this is for the Java ecosystem. That's why all the frameworks they recognize and they started providing this metadata information to the Oracle. So everyone worked together, and now most of the GraalVM is stable, and you can convert any of the Spring Boot application or Java based application as a natively executable code with the help of GraalVM. Whenever you have some exceptions inside your web application, which you are trying to start with the help of native executable code generated by the GraalVM, try to understand which framework or which library it is throwing that error. Accordingly, you can convey to the GraalVM to look into these metadata. So let's try to see how to configure those changes inside the pom.xml. So inside this pom.xml, we have a plugin related to the native Maven plugin. So inside the same place, we need to provide more details. So here we need to provide configurations with the help of this metadata and enable it with the help of true. And please always use the latest version, which is 0.3.2. So if you see inside this GitHub repo, the current version is 0.3.2, which released on June 9th. So always try to use the latest reachability metadata information. So I have mentioned the same here. So with this, we should be good. Any issues that you are getting due to dynamic code inside your web application should get resolved. But if there is some third-party library which is not provided this metadata information, then definitely you have to do by yourself, or you need to ask them to provide this metadata information to the GraalVM. So if you try to understand how this metadata is going to look like, so let me open for one of the famous library, which is Hibernate. So here for the Hibernate core, under this 6.2, I'll open one of the reflex config.json. So all your reflection classes, all your reflection usages, you need to mention by following this JSON structure. You can see there is an JSON array, and inside this, there are multiple class details provided by the framework. And similarly, if you are using any dynamic resources, you need to provide them inside these resource config.json. This way, you need to request your third-party library to follow the same standards and provide the metadata information to the GraalVM. So this should resolve for any kind of runtime code related issues with this metadata repository. For some reason, if it is not working, please add a dependency manually inside your pom.xml. Here we have added a new dependency, which is GraalVM build tools. And this dependency is going to look for this metadata configuration and use correspondent version that you have mentioned. So let me load this Maven changes. So the version cannot be empty for these dependency. So let me mention the version here. The current version that we have right now is 0.9.21. So I have mentioned the same and I'm doing a build. So this compiled successfully. So I'm just providing this extra information so that in future, whenever you have some dynamic code related issues, you need to follow these steps. So this is the very first challenge, which there is a workaround. By following these reachability metadata, you can easily solve this. And the second challenge that we have here is during the build time, whenever you're trying to generate a Docker image with the help of natively executable code, or whenever you're trying to compile your Java application with the help of GraalVM AOT compilation, then like I said, it is going to ask you a lot of computational efforts. You need to provide powerful missions. And at the same time, you should also know what is your target platform where you're going to deploy. Suppose if you are trying to deploy into a Linux server inside your production, you can't compile your code inside a Mac OS or Windows OS, because whatever natively executable code that is going to get generated, it is going to specific to your local platform. That's why always make sure you are aware of the production platform target and OS, and use the same platform and OS inside your build servers. So this challenge, I think it should be fine, because anyway, we are going to generate a Docker image, or we are going to do a build only once whenever we want to deploy into a production. So if you can wait for 5 minutes or 10 minutes, eventually you can take that executable code or Docker image to the production, and you can try to run any number of times. You can try to create any number of instances. You can try to scale your application any number of times. And in that process, you are going to get instant start time, which is a major advantage that we have with the GraalVM. And at the same time, your code also is going to consume less resources at the runtime, like less memory, less CPU usage, which will eventually convert it into a less cloud bill. And the last limitation is during local development and unit testing, it will be very annoying to use the GraalVM JDK, because for every build, you have to wait 10 minutes or 15 minutes based upon your laptop. So that's why GraalVM team recommends use the normal JIT compilation during your local development and unit testing, and go for the AOT compilation only during the final build process or inside your build servers. So these are the limitations. According to me, these are not great limitations. There are workarounds provided, and GraalVM has a long way to go. In the coming years, I'm sure they are going to overcome these challenges, and at the same time, they're also going to improve the performance to a great extent. So this is going to be super addition to the Java ecosystem, and this is going to be a game changer also in many cloud native applications. I hope you are clear with all these advantages and limitations. Now let's go to the terminal and see whether the Docker image is generated. The Docker image generation is successfully completed, and you can see it took around 30 minutes inside my local system. Maybe because I'm using my system to a great extent along with the recording softwares. If you have a decent mission which is sitting ideal, you should be able to complete this process in 15 minutes. And my Docker image name is generated. It's my bad. I have used the same tag, which is normal, but that's fine. We should be able to validate the changes. So let me clear the console and run the Docker images command. So this time you can see the previous Docker image that we have is marked as none, because we have used the same tag, same Docker image name. So it has around 314 MB. Now the latest Docker image that got generated based upon the natively executable code Right now it has only 204 MB. So you can see the improvement more than 100 MB is reduced, and this is going to be a game changer in many places. You need less space to store your images. Your containers will take less memory, less CPU utilization at runtime. They are going to provide instant start time. So what else you need to save your cloud bill? That's why many companies, they are already using GraalVM, and soon you will be seeing that this is going to be a mandatory skill for any Java developer. So now I'll try to start my image as a container. Like I'll try to run the same command, docker run -p 8080 easybyte/account:normal. So this time let's see how much time it is going to take. So you can see my Docker container started in 2.4 seconds. Previously it was taking more than 30 seconds. So there is a drastic improvement. Now my container is starting within 2 seconds or within 3 seconds. If you are looking for instant start time, then don't convert your application as a Docker container. Directly deploy your natively executable code and you are going to get instant time. So with all this, I'm assuming now you're super clear about GraalVM and you became a fan of GraalVM. I'm also liking GraalVM these days a lot, and I'm going to use this a lot whenever I'm trying to build cloud native applications like serverless, Docker containers, microservices. I hope you're also going to do the same. So before I try to close this lecture, I just wanted to highlight 2 points. The very first point is kudos to the Oracle GraalVM team for providing such an amazing product, such an amazing JDK. They are taking the Java ecosystem in a right direction. All these days, I used to worry a lot of innovation is happening on the SpringBoot or Spring side, but not on the Java side. But now I see both of them are competing with each other. Oracle came with a GraalVM, SpringBoot is coming with a lot of improvements. So this is going to be super fun and make our lives easy. The second important note is, if you like this video, please like it, please subscribe to the channel, and that will give a lot of motivation to me. Thank you for your time. Bye.